Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. Well, I'm super delighted to have Bart Vanbrabant, CTO from Inmanta. Bart, welcome to Executives at the Edge. If you can please tell our listeners a little bit about yourself and the company, that'd be really great, and we'll get into some really great conversations about all the things that you do.
So I'm from Belgium. Inmanta's from Belgium as well. We were founded in 2015 as a spin-off of the University of Leuven, and the technology that is the underpinning of our product was something that I built during my PhD that I did at university. So we founded it together with some colleagues and a professor. And then we built a service orchestrator.
Well, thanks, Bart. That's really great. So, what, for our listeners, what is a service orchestrator? And by the way, very impressive that this came out from your idea in your dissertation, right? That means that's impressive. And then you take that and you make your own company. I mean, that's super impressive. Hats off to you.
I started it as a student in my master thesis, and from there I've done this entire professional life. So I've been doing this for 16 years now.
That's incredible. Hats off to you.
Service orchestrator, what we do is we take from the BSS at the product level. If you take the MEF-LSO architecture, we take the intent of what you want in your network, and we make sure that it gets in your network. So we are a really intent-driven service orchestrator. So you only tell us what you want in your network, and we will always look at what is currently there and then determine the optimal workflow to get there.
So help our listeners, just to walk through the workflow. So a customer comes in through a portal, or they use APIs. They look for products and services, and they want that, or buy it, get quotes, order it, provision it, all that stuff happens. That happens at the BSS layer, but that has to come eventually down to your orchestrator that has to do it.
Yeah.
So in the past, even we had those business systems, the BSS systems that had the quote and the ordering, the product. In the past, people would actually go and take that and then program that with the network and CLI or download CLI scripts or whatever. But it was a manually driven model.
Mm-hmm.
And what you've done is you build out from that process of business systems to flow that into this machine called a service orchestration that replaces those people. And now machine-based programs and configures the network and makes sure it's all done right, tested even potentially. I don't know what. No. So explain, do I have that right?
Yeah. So the goal of the service orchestrator is once you've got your business processes automated, to go to 100% automation.
Yes.
So we have customers that have services that took 8 weeks to deploy. They now do this in 3 minutes. The way that we do this, we get this high-level intent. It references inventory items. It references various systems in the BSS. In the orchestrator, we take this order, we start enriching it and starting to refine it into the details that we need to deploy the service into the network. And then we start deploying it in the network. We also closely interact with an inventory system.
Yes,
we get information from the inventory system, but we also think it's very important to always document what we do as an orchestrator. So we program the network, but we also program the inventory.
Of course, you have to update the inventory.
And that means that your inventory is always completely up to date. I think one of the things that makes us unique is that you don't tell us how you want it how we need to make the changes in your network. You just tell us what you want in your network, and we will figure it out. That makes it very resilient. When something fails, we can just retake the process, and we will find a way to get the service there. It also means that if you go into a brownfield environment and you want to start onboarding existing services, that we can just automatically start onboarding them and fix them as well to make them compliant with the service design.
Excellent. So let's go back to intent. So what do you mean by intent? Because I'm not sure our listeners all know what intent means. So basically, if I say I want to go to the airport, I want to go by a certain time, I don't know if I'm going to take a helicopter. I don't tell them, hey, I want a helicopter, I want a car, I just want to get to the airport and I want to be there by a certain time. How you get there and by maybe a price. So
the analogy that I often use is when I was a kid and we would go on holidays, my dad would spend hours and hours creating this road book. And then he would have, for every turn that we need to take, he had this road book. And then the moment we would hit France, there would be déviation, which means detour. And then your road book, it cannot help you anymore. Intent-based is like a GPS. You say, this is my destination. And whatever happens, the GPS will always reroute you to go to that destination.
That's awesome. That's a better analogy than me.
My dad doesn't like it that I'm always telling the story, but
that's good. That's good. And these are intent APIs, but the more lower level ones where the map was all routed out was what we call imperative APIs, right?
Yeah.
Which you try to stay away from. Now, in MEF, what excites you about what we're doing with the service orchestration and our APIs? Now, specifically, you probably care about Legato.
Yes,
right?
yes. So Legato is our API. What we think is important is that the service orchestration offers a level of abstraction to your network. You do not want network level details in your products, in your BSS. That if that is the case, when you switch out a vendor or you change a product definition, these are very expensive, complicated processes that take months and months. You need huge budgets just to make small changes. By having this layer of abstraction in between, you entirely decouple the network operations and the BSS system. And what MEF provides is both the API and the product specifications. For us, the product specifications are even more valuable than purely the envelope, because that gives us a language that we can expose to the BSS, where when you talk about carrier Ethernet, those map almost completely one-to-one to the product specification. And there is nothing about vendors or specific technologies in there. And we have a customer case where we have been adding additional features. We're introducing new vendors. We switched from legacy signaling to EVPN without making a single change in the BSS.
That's perfect.
So they can just switch out parts in the network and it's entirely decoupled.
Is that what the problem with the providers in the past were with the OSS systems and the BSS? It was you made one change in the network, it had huge impact. It was a spaghetti mess of integration.
So it's very closely
tightly integration.
It's tightly coupled. It has no modularity. That also means that often when you have a new product, you need to start from scratch. The existing automation is, if there was automation even, it was unusable. We allow you to do this very modular and composable. And then what you brought up as well, testing is very important. We try to convince our customers to create digital twins for the network every single time. When we assist our customers with the professional services, then we built a digital twin in our lab as well. And every night we run 150,000 test cases. I think we deploy about 5,000 E-lines every day in our lab to test every possible problem that we think can happen. When a customer reports an issue, we always put test cases in place so that they never happen again.
So for our listeners, can you explain what a digital twin is? I know what it is, but I think it's great. Sometimes we take for granted things, and I just want to make sure our listeners know.
So a digital twin is a digital representation of your network. For orchestration, this is, I think, one of the places where it's not that difficult to do this. You don't need performance testing for orchestration. So for us, the orchestrator has succeeded when we can send a ping across. We don't need to do load testing. We don't need to do performance testing. And that means that I have some of my engineers on my team, they have a digital twin running on their laptop of a customer project. Most vendors now provide virtual machines for their equipment, often not for production use, but for testing use. And so you can easily create a digital twin, and then we create an automated test suite that allows you to make sure that every time you run a test, you start from a well-known state. And then we run through full scenarios, good weather flows, but also the bad weather flows, to make sure that the orchestration behaves as you want, as you intend, when something goes wrong.
No, that's pretty. No, we used to call that simulation.
Yeah.
You know, when I was growing up.
Yeah.
But basically now we're calling it digital twin. But in essence, you're doing a simulation.
Yeah, absolutely. Or something virtual. That's a virtual world, so indeed it's a simulation. But the new term for this is digital twin.
It's definitely. But I think what you're actually saying is your digital twin is spun up automatically from the inventory. Like in these old ways of inventory, you had to build out the network, build out the links, the capacities. They were manually driven instead of like discovered for the inventory.
For service orchestration, you don't need a digital twin that matches the entire network.
Of the inventory.
Often that's not required.
Okay.
What we try to do is make sure that our lab environment, the digital twin environment, allows you to test all the scenarios that the service provider wants.
Okay.
So in carrier Ethernet, this is the different vendors that you want, multi-homing versus single homing and so on. But typically if you have those, you can test 99% of all of the cases automatically. I think that's an important message as well, that this automation is really important, testing as well. But focus on the things that are easy to do, because often you can get to 90 or 99%. Instead of focusing immediately on that 1% that's very difficult and say, no, it's not going to be possible.
It's a good point. 80-20 rule, right?
Yeah, absolutely. Yeah.
So really you like the APIs, what we've done, because we've got this polymorphism, which means that the APIs of creating an order or, ordering and then updating inventory has nothing to do with the actual product or service. That's carried in a different part. We call the payload, you called it. Mm-hmm. And the payload could be carrier Ethernet, it could be internet, it could be pizzas. But that's the point. So what do you see as the challenges for the industry to adopt this end-to-end automation more quickly?
I think it comes down again to this 80-20 rule. Just get started. It's what we see now is often over-analyzing all of the... engineers tend to focus a lot on all of the difficulties that are there, instead of focusing on what would bring lots of value. We had this discussion with customers where they say, yeah, but we first need to do a big inventory project to make sure that everything is in our inventory system. And then we need to get new equipment in place. But if you look closely at the services they have, often they get a huge amount of revenue of only a few points of presence and a few large customers. And so if you can start focusing on those with a minimal viable prototype, you can get results very quickly. We tend to get results within 3 months, getting something in production. And then you can start learning how to automate. And what we see now is due to lots of legacy, lots of heterogeneity, operators tend to start with these big bang projects with a huge amount of stakeholders involved. And then it becomes very complex to get something off the ground.
I travel the world talking to many operators as my job, and I find that in some parts of the world, I won't name them, they basically don't understand how to get to operation, how to get to automation.
Yeah. Mm-hmm.
They're just confused, and they just need help. They understand that the coding function is very important in the BSS because everyone wants to get a price code. Then they go from the coding to the ordering. But when the ordering and then the updating the inventory of the ordering is done, the flow through to what you're describing to actually do it in the network and not people, their argument is, I have cheap people. I can get them to do it for cheap. They've been doing it forever. They know it inside out. And I always say to them, it's getting more and more complex.
Absolutely.
And on top of it, the human error factor is massive. And we've seen outages that can take down huge networks. I won't say who, but you see that all the time.
Yeah, we know.
And to your point is this service automation that replaces people are machines that are very precise. And with this, well, called simulation, but this digital twin capabilities, you can really predict a lot more and accurately before you do any change.
When you look at the SaaS world, they're saying test in production. But in the telecom world, what we're actually trying to convince our customers is to stop testing in production and try to do as much as possible before production.
Of course.
And the results are that we have our customer, the first customer went in production in 2020. We've had 0 outages. We had 0 major defects.
That's amazing.
We had lots of them before production, which is normal. We're doing software, but we catch them before production. And that's the thing you want. It's safe to do things before production. Once you get into production, the stakes are much higher.
Yeah, so that makes total sense. Look, we're all realizing the world's moving to automation. It has to be, it's a must-have. And as we go to a cloud-like experience, which every enterprise wants, operators have to deliver that cloud-like experience. And it can't be, oh, well, here's the quote, here's the order, but wait, it'll take me 3 days for someone to configure that, right? We know that from the hyperscalers, that happens right away.
Yeah.
Right. And what you're saying is that's what your systems do.
We have a customer, and they're actually seeing customers coming back to them, because now their customers know when we need a carrier Ethernet or a connection to a cloud provider, we just log into the portal and 3 minutes later it's there.
That's incredible. That's awesome.
And they see double-digit revenue growth. They have 70% OPEX reduction by doing the automation. And then something that I really like is they say they have a reduction of 89% in time to bring new features into production.
So can you do wavelengths? Can you do carry Ethernet, internet? Would you be able to even provision like SASE and SD-WAN and
absolutely? The technology was actually developed when cloud boomed. So I did my PhD. I finished it. I defended it in 2014. So it was top cloud hype, and the technology was built for complex distributed systems. And a telco environment is a very complex, large distributed system.
Exactly.
And you have connectivity, you have data centers, you have clouds. We can orchestrate all of that from the same system without having those different silos where you need to duct tape things together again.
Exactly. That's perfect. So what's your advice to operators, their CTOs and their executive management who wants to accelerate digitalization and the end-to-end automation projects?
Just get started. Get started with small projects, typically those new products that you want to launch, and then try to get into production as quickly as possible. It's new for everybody. Find experts like Inmanta. We're experts in automation, but every network is unique. Every environment is unique. So you need to be very agile. Don't wait a year or 2 years before going in production. Do this as quickly as possible, and then learn from the mistakes that you will inevitably make. But you can quickly iterate and do new things, and that allows you to compete and to digitalize very quickly and build this kernel inside your company of people that are entirely into automation, and it will gradually expand.
I wholeheartedly agree, and I think you're spot on. But do you deliver some consultations that helps them in that journey?
We are a product company. We, as a company, also provide professional services and architecture and so on to our customers. And we're building out we have some partners, and we're building out this network of partners that can assist the telcos with this.
I think that's probably the most important thing, because they do have legacy OSS systems, and they don't know how to get rid of it in some cutover, because not everything's a greenfield. They're all brownfields. And absolutely. So you're going to have, you manage that well in brownfields environment. You've seen successful ways of conversion.
Absolutely. We like the successful use cases we have. Those were existing services where they started with automation, and while we were doing the automation, they still provisioned new ones manually. And then at some point, they did the cutover for one friendly customer, and then 2 customers, and then they expanded to more points of presence. And now we're onboarding circuits that were created 10 years ago. So this is a long process, but you need to learn. And it's easier to learn with a friendly customer and a new circuit than one that has been active for 5 years already.
Well, Bart, this is being extremely valuable and insightful, and I'm sure our listeners will think the same way. And I want to thank you for your time.
Thanks for having me. It was a pleasure.